Right, so as per usual, let's go ahead and create a new project. So here, File, New Project, and give it a name. So I'm going to call it Module 4, and let's do an underscore, call it week 1, and then I'm going to save it in my D drive, with my 2 dots. Leave all that, that's fine. Click accept. File, save as, and then insert job here, and then create your actual scene, your hip. Okay, so I'll just call it week 1, version 1, accept. Great. Okay, so I'm just going to start out. So here, that's what you'll see normally. I'm just going to jump into my Pyro shelf tools here. Okay, so something that's new to Houdini 18, I believe it is 18. I don't think it was in 17. Is this idea of sparse pyro. Okay, so I'm just going to use some of the shelf tools here just to go over, you know, what that means, and just to take a quick overview of pyro. And for our first week, we're going to be doing a kind of billowy smoke thing. We'll build it ourselves, but just to start off, we'll use the shelf tool to have a look at the whole kind of setup. Okay, so just click that, and then you can see it's asking me to select the location. I'm just going to press enter without clicking. I'll just drop it in the center. Okay, so this creates a source, the actual simulation DOP, and then the imports from the simulation. Okay, so let's go through step by step here. So we've just got a sphere, a primitive sphere. You can have any kind of polygonal or primitive geometry here. And then from this, we generate points. Okay, so there you can see there we're generating points. In a volume, so they're inside. You can also just kind of scatter the points on the surface or keep the input. So in this case, it would just be the 1 point because it's a primitive. And then on these points, we're generating 2 attributes. Okay, so these are just standard point attributes, density and temperature. You can see them here. Okay, and they're all the same. Oh, and we do have p-scale as well. We're generating, okay. And temperature, and you can see it's the same on every point at the moment. And then we can add noise to that, to those attributes. So you can see them here now. We're changing. We're going between 0 and 1 for both, and they're being affected the same because we're, you know, we got density and temperature in there, and you know, a whole bunch of settings in here just to randomize that a little bit. Then we take those 2 attributes, density and temperature, and we convert them into a volume, okay, ready to go into our simulation. So we do need a volume to go into our simulation. So there you can see we've got the density and the temperature on top of each other. So if we take a look at the information for this node, you can see we've got a density volume and a temperature volume. These are Houdini volumes. Or are they? No, they're VDBs now, actually. And they are... you can see the size of them here. Okay, and yeah, that's ready. So you know, that's the basics of what you need. You could, depending on if you're doing fire, you would have different attributes. Okay, so, and you might also include velocity. We don't have any velocity here. You might include burn for doing fire. Okay, you know, there's a few others, but these are the typical ones. Density and temperature, you're pretty much always going to be sourcing in. Okay, so we go from there into the simulation. So remember, we got this output, and then that is sourced into here. Okay, so this is the new Pyro sparse solver. Okay, so that's different to the old Pyro solver. So that's the standard. So we got 2 different solvers. Okay, you can see this one's green and this one has this kind of funny symbol on it to indicate that it's a sparse solver. They're very similar, but not identical. And to go with your new Pyro sparse solver, we have the sparse Pyro object as well. So it's important to, you know, make sure that you're using them. So I'll get back to what that means in a minute. So there we got these same attributes here. Okay, so we are looking at that out in the source. Okay, so we're getting those volumes, sorry, from that source SOP, the out SOP there, and then here we're getting the density, which was the same name. Okay, this has to be the same name, and the temperature, and we're targeting, so we're connecting that to the volume within the simulation called density. There they just have the same name, and temperature. Now these have to be called density and temperature. You can't change them, but you could change these. You know, you can make up any, you know, you might have, I don't know why, but you might have different types of density, you know, density 1 and 2, or I don't know, big or small, or, you know, different types of noise, whatever you wanted in SOPs. And then, but when they come into the solver, the target field must be density, temperature, and so on. So let's take a look. We'll just simulate a few frames. See that we get something going on. Okay, so obviously pretty low res. Might as well, we can drop it down a little bit. By the way, yeah, whether you copy me or not now, it doesn't matter. You know, this is not going to be, oh, what's going on there? That's strange. I think I've got my, there we go. You know, we're not going to be using this for our final simulation later, so, you know, I'm just doing this to show you. So we'll just simulate a few frames there and then talk about this. So you can see that we got the density pushing up our, we got the temperature, which is pushing up the density. So we can visualize, if we come into the smoke object, we can visualize the temperature, I believe. Okay, and then maybe if I turn off this multi-field, so there you can see the actual dense temperature field that we're importing. So that's the temperature, and you can see it's kind of pushing everything up. So wherever is hotter, the faster it goes up. Okay, and that's controlled by the buoyancy settings here, temperature and buoyancy. Okay, so I could do this. I could drop the actual temperature down, and then that should mean it would go up slower, or it doesn't even rise there, see? So because now the temperature I'm bringing in is the same as the ambient temperature around, there's no buoyancy, it's not going up, right? So if I right click, set this back to default, so now is the temperature of 1 is, this is kind of, you know, to give you an idea, so this would be the same as the temperature in real world. So if you're doing like a small fire, you can look up what temperature in Kelvin would that be, and you can put that value in here. And you can do this with this buoyancy scale. We could, you know, put that to 5, and then it will rise, should rise much quicker. See that shooting up now. Okay, so you can play around with these values. So let's take a look at the actual sparse, what we're using, multi-field here to visualize it. So what that means, the sparse solver. So we'll simulate a few frames, and then what I'm going to do is turn on this active region. So here, this is what it's all about. So you can see this boundary, these boxes show you what is actually being simulated. Maybe if I, hopefully we can see it better like that. There we go, yeah. So yeah, whatever is inside this kind of boxy container is what the solver is actually calculating. Okay, so anything kind of around here is irrelevant. It's not bothered by this. It's not being calculated. So with the traditional solver, the other Pyro solver, everything, you know, it had to have a cube, or well, had to have a box to calculate, and everything within that box, even if you only have smoke in one area, or, you know, when you've got kind of lots of different small bits of smoke, it's calculating that whole space every frame, and it, you know, it can get very slow and very inefficient. So that's basically in a nutshell what is meant by the sparse solver. Okay, it just saves you a lot of time, and as long as you set it up with these, you know, that'll work for you. You can see it's turned on there. One thing to keep in mind is that you cannot use, if I could find it, I think in advanced, OpenCL doesn't work with sparse solving. Okay, but typically, you know, the speed gains from using the sparse solver are better than using OpenCL. If you've got something, you know, a simulation which is basically like a block, if it's kind of smoke in a square, like filling a room or something, then maybe you'd want to use OpenCL. But typically, you know, I would just default. So now it's working, but it's turned off. You know, the sparse is not running, I think I might say here. Yeah, see, sparse solver is not supported, so it's not running now. Okay, so that's the basics. So you know, obviously we're going to be talking about this much more later, and then those same fields are imported here back into SOP, so you can start with shading or, I don't know, setting up your scene. So here we're importing that same field, density. We've got velocity now, you know, which is generated within the solver. Flame, we're not, you know, we don't have any fire here, and temperature we're importing as well. And then you can kind of do some look stuff here. Now I'm just going to delete these and create a geometry node and dive inside. So I'm just showing you these as well because they're a good thing to look at as a kind of reference. You know, you can start with these, you know, if you can do your final simulation with these, but I typically tend to use them for kind of problem solving. If I like to set up everything just node by node myself. It just gives me a better understanding of what's going on. But you know, when it comes into trouble, if there's something that's really not working or just looks weird, it's good to just use one of these to see you know, the setup that works basically. So I'm going to dive into this geo and press tab and go to this pyro option here, and here we can see we've got these pyro configure, billowy smoke, fireball, and spreading fire. So let's do this billowy smoke. Now I drop that, and you can see that gives me a string of nodes, just 5 nodes, and here we've got a pyro solver in SOP. So this is also another brand new thing. I think this pyro source is new as well for Houdini 18 or 17, I can't remember. Okay, so now we've got this new solver which kind of wraps up on the inside. If you dive inside there and then go here, you can see it's just a .NET with that pyro solver, the pyro object, and a few other bits and bobs, colliders and everything all set up for you, ready to go. It's a real time saver, and you know, works really well, and you know, that's working straight away there with a really nice simulation. Okay, so again, we'll be doing something pretty similar to this. You know, it's the kind of standard workflow now of, you know, object, create points, add noise to those points, and then rasterize that into your simulation. Okay, and we'll start out with this pyro solver in SOPs as well, and in the other weeks we'll continue with a DOP, you know, building everything in DOPs to have a bit more control. Okay, so I'm going to delete that. I'm going to come out here and just give this a better name. We'll call this smoke, like that. Save it, and then we'll continue in the next lesson.